So now we're going to see together the new compute features that were presented at the last re-event. And as we're talking about compute, so let's start with a picture of a piece of hardware. This is a coprocessor. You might see written on it Annapurna Labs, which is a startup that was acquired by AWS. What's interesting about these coprocessors is that they are coming with a system called Nitro. This Nitro system is used on servers that accelerate the virtualizing process. So they have two main advantages, one from performance point of view and the second one from security point of view. From the performance point of view, AWS claimed that some of their clients tested the performance and seemed to be similar to bare metal. The difference is less than 1%. And based on this, AWS went further and built ARM-based EC2 instances that will be powered by AWS Graviton 2 processor. So this new processor has 64 real cores. There's no multi-threading on them. Networking bandwidth is above 20 gigabytes. And besides good performance, they offer good quality-price ratio. On similar performance, they are up to 40% cheaper than the equivalent Intel or AMD processors. They come in 3 different families, M6G, C6G, and R6G. G stands for Graviton. M is general purpose workloads family. C is from compute, so everything that is compute intensive workloads. And R for RAM, memory, everything that is memory intensive workloads. So now that we saw the performance about the Nitro system, let's see on the security aspect. So on the security aspect, we're going to talk a little about the Nitro hypervisor. So in order to understand the security aspects of this new Nitro system, let's take a pretty common question that any AWS user might have at the beginning, or even afterwards. And the question sounds like this: what stops an AWS employee, an admin, from connecting to the hypervisor and possibly accessing client's data? Because we will imagine that physical is possible. To answer this, AWS has a whole set of use technologies and processes to control that and to prohibit it. But now, with Nitro hypervisor, there is not possible anymore to connect to the hypervisor because there's no command line, no graphical interface, no way for a person to connect. The Nitro hypervisor only accepts commands that are coming from the so-called control plane that is encrypted and signed, meaning that only you as a client have the power to give commands to the hypervisor. But there's maybe a second question, and you as a client would like to stop your admins from connecting to the hypervisor. And how could you do that? Well, the answer to this is AWS Nitro Enclaves. Enclaves are an isolated, hardened, and highly constrained environment to host security-critical applications. We can say that they're fully virtual machines that have no persistent storage, no operator or administrator access, and have only secure local connectivity. So AWS Nitro Enclaves might be the answer for everything that is sensitive data that you want to protect or to securely process. Now let's move to compute costs. AWS Compute Optimizer is a new service that helps you to optimize compute resources for your workloads. So it's using machine learning techniques to analyze the history of your resource consumption on your account, and based on that is making recommendations tailored to your needs. AWS Compute Optimizer is well integrated with AWS organizations, meaning that from your main account organizations, you can see the recommendations that are created from multiple accounts. So also AWS Compute Optimizer is using Amazon CloudWatch metrics to make the recommendations. And bear in mind that CloudWatch metrics are the ones it can observe from an hypervisor point of view, such as CPU utilization, disk or network IOs. But if you want to have a view from the operating system level metrics, such as memory usage, then you'll need to install a CloudWatch agent on your EC2 instance. Another service that was announced 1 month before re:Invent is Saving Plans. So this is very interesting when you ask yourself what would be the most efficient way to reduce your costs on EC2. Before Saving Plans, on a medium long-term perspective, reserved instances was the answer. So for those that are not familiar with the reserved instances, when you take a reserved instance, you commit to use a specific kind of instance in a specific region for 1 or 3 years. And you will build on it if you use it or not. So imagine that you enable Cost Optimizer that we just saw, and that is free. And you realize that you don't need a compute instance anymore, and that an instance from a general purpose family would work just fine. And that instance is cheaper. Or that you need to deploy new instances in another region. With reserved instances, normally you will have to buy new reserved instances. But with savings plans, things change. You do not commit anymore to use a specific instance type in a specific region, but you commit to use a specific amount per month of compute power over 1 or 3 year period. Say the savings plans automatically applies to any EC2 instance, regardless the region, the instance family, the operating system, or tenancy, including those EC2 instances that are part of your used managed services. You can switch from Windows to Linux while continuing to benefit without having to make any change to your savings plans. Let's move forward to serverless features. So provisioned concurrency for AWS Lambda is a feature that keeps functions initialized and hyper ready to respond very, very quickly. Imagine that you use AWS Lambda functions and that you're invoking a Lambda function that wasn't used for a while. In that case, the invocation was routed to what is called an execution environment, which has to be created, and this might take some time. In this case, some latency might be introduced, and this latency is well known to be named as what we call cold start. But when you enable provisioned concurrency for a function, the Lambda service is initializing the requested number of execution environments so that they can be ready to respond to your future invocations. Here we have an example of 2 Lambda functions, where we see the percentage of the requests served within a certain time. In blue, we have a Lambda function with the provision concurrency disabled, and in orange, we have a Lambda function with the provision concurrency enabled. We can see that between 95 to 100%, there's a difference between 2 in the response time, and the Lambda function with this option disabled is serving the requests with an additional 1 second. Then the Lambda function with the provision concurrency feature enabled. So this is very useful if you're dealing with cold starts. And It can be used to implement interactive services, latency-sensitive microservices, or synchronous APIs. Amazon EKS for AWS Fargate. So EKS is Elastic Kubernetes Service from Amazon. Maybe you are already familiar with Amazon ECS for AWS Fargate, Elastic Compute Service for AWS Fargate, that orchestrates different containers like Docker. And in 2018, they introduced AWS Fargate for EKS, meaning that Fargate allows you to deploy containers without handling any EC2 instances. So this is now also available for those using Kubernetes. And also, what's interesting about Amazon ECS for AWS Fargate, since yesterday, it's possible to have persistent storage for Fargate via EFS. Then here we have a couple of container services. AWS Fargate Spot. If you're familiar with EC2 Spot instances, the concept is the same. AWS uses spare capacity in the AWS cloud to run your tasks. When the capacity for Fargate Spot is available, you will be able to launch tasks based on your specified requests. And when AWS needs the capacity back, the tasks running on your Fargate Spot will be interrupted within 2 minutes of notification. So you can run interruption-tolerant tasks and have up to 70% discount of the Fargate price. The next one is Amazon ECS capacity providers. So you'll have additional control over how your applications use compute capacity within your EC2 auto-scaling groups and when using AWS Fargate. So you get an abstraction layer that lets you make late binding decisions on capacity, including the ability to choose how much spot capacity you'd like to use. Amazon ECS CLI version 2. So this is a new open source command line that focuses on delivering an end-to-end experience for developing and deploying applications on Amazon ECS. Last one, ECS cluster auto-scaling. This new capability improves your cluster scaling experience by increasing the speed and reliability of cluster scale-out, giving you control over the amount of spare capacity maintained in your cluster, and automatically managing instance termination on cluster scaling. So these were the container services, and now we're moving to the last compute service, EC2 Image Builder. So this allows you to automate the creation and the deployment of the secure virtual machine images, or what we call also golden virtual machines. So for those that are not familiar with golden virtual machines, these are customized virtual machine images that come pre-installed and pre-configured with all of the software, the scripts, the configuration that you want as your ideal state, and many of these are hardened to meet either internal or applicable industry regulations that you might want to meet. So with EC2 Image Builder, you're able to define these golden virtual machine templates and so you can either choose a source image that you already have or use a managed image. Is working both with Windows and Linux. And they also propose collection of test software or security tests that you already developed and you can use directly.